Hi everyone, today we're going to be looking at lesson 4.2, which is model and graph with functions. Your learning intention for today is I can create and interpret graphs that model a function word problem scenario. So for the launch today, we're looking at a word problem. Our job is going to be to create a graph that represents what's happening in this problem. Sylvia has a small pool full of water. It needs to be emptied and cleaned and then refilled. And so here are 6 tasks that need to be completed as a part of this process. Let's go through and number them 1 through 6. Now it's important to note that these 6 tasks aren't happening in this order. It's going to be our job to read through the problem and make sense of what order they would happen in, and then we'll use that order to create a graph that shows what's going on. And so that's our job right here. We're going to sketch a graph showing the height of the water level in the pool over time. We're going to include all 6 activities that she did, and we're not going to forget to label our axes. So let's start with labeling our axes. So we'll let our x-axis represent time, and then our y-axis is going to represent the height of the water level in the pool. It's important to note that with this graph, we're not going to scale the axes, so we're not going to put numbers on them because this graph is going to just represent what's happening over time. The directions to the problem indicate that the pool starts out having water in it, and so we'll start our graph from over here on the y-axis. Let's say that for starters, Sylvia began by working by herself, so she was removing the water with a single bucket. We might indicate that decrease in the height of the water level in the pool by a line segment that goes down like this with a slightly negative slope. Perhaps at that point, Sylvia got tired and took a break, and so we would represent that break with a horizontal line showing that during that time, the height of the water level in the pool remained the same. At that time, it might make sense that Sylvia's friends started helping her, and so if she and her 2 friends removed water with 3 buckets, the line would also be going down, but it would be going down more quickly than that first part of the graph was. And then after that portion of time, that could be the time when they drained the water with the hose at the same rate as filling the pool. At that point, the graph would intersect the x-axis because we would assume that at that point, the pool would be empty. During the next portion on the graph would neither rise nor fall because that could perhaps be the time when the girls cleaned the empty pool, so the water level in the pool would remain 0 at that time. And then the final portion of the graph would be filling the pool with the hose at the same rate as emptying the pool. And so that line segment would be going up at the same rate that the last downward line segment was going down, so we would try to mimic that slope. Since the pool was being filled back up, we would try to show that the graph ends here at approximately the same height that it began. Now, what our graph is missing is labels that help show what each of these 6 line segments mean. So I'm going to go back through and add those using the numbers that I described above. The first line segment of the graph was Sylvia removing the water with a single bucket, and then she took a break, and then she and her 2 friends removed water with 3 buckets. Then they drained the water with a hose, then they cleaned the empty pool, and then lastly they filled the pool with a hose at the same rate that they had emptied it with that hose. And so by adding the numbers onto the line segments of the graph, it helps you correlate them to the descriptions up above. The final question here asks if our graph represents a function, why or why not? The answer to that is yes, the graph does represent a function, and then there are different reasons how you can explain why. You could say that the graph passes the vertical line test. You could also describe that at no one point in time does the pool have 2 different water levels simultaneously, and so those are all reasons that you could use to describe that. Interpreting graph also involves looking at a picture of a graph that's already been drawn for you and answering questions about the graph. Here in this example, my x-axis represents time, and the y-axis represents a rocket's height above the ground in feet. And so we can interpret what's happening here on the graph as well. The rocket's height is rising quickly, and then at the apex here at the top, it stops rising. Here the rocket is falling quickly, and then at this point right here the parachute opens, and then for the last portion of the graph over here, the rocket is falling slowly back to the ground. The question here asks us to interpret what's happening at the 2 x-intercepts of the function, and I've highlighted the 2 x-intercepts of the function over here in yellow. At the 2 x-intercepts of the function, the rocket starts on the ground and then returns to the ground. So those 2 yellow x-intercepts represent points in time where the height of the rocket above the ground is equal to 0. In this next question, we're using the following verbal descriptions to describe each labeled segment of the graph. Notice on this graph our axes are not labeled and the situation is not defined, so we don't know what this graph represents, but we can still describe the slopes of the line segments. The steepness of each line segment indicates how quickly that portion of the graph is changing. So the difference between A and B is that at A the graph is rising slowly, and then at B the graph is rising quickly, and we can tell that there's been a change there because there's a point between those 2 segments, and you can tell that it's rising quickly versus rising slowly because the slope of those line segments have changed. At segment C, the graph is neither rising nor falling. That's an example of where the graph is remaining constant. And then looking here at the last 2 segments of the graph, at both D and E, the graph is falling. At D, it's falling more slowly, and then at E, it turns, and that line segment appears to be steeper. So we would say that at D, the graph was falling slowly, and at E, the graph was falling quickly. Make a note here that the steepness or slope of the line segment tells you how quickly either the speed or the rate of change, whatever the graph graph represents is changing. All right, here in this next section, we're looking at a word problem situation. It says you're buying concert tickets, and it's a bargain concert, you guys. They only cost $15 each. You can only buy up to 6 tickets, so there is a limit on how many you can buy. The first part of the question says to write the amount in dollars you spend as a function of the number of tickets you buy, and be sure to define your variables. So let's have T stand for ticket, and then we'll have A of T stand for the amount of money that you spend on those tickets. Tickets cost $15 each, so our function here would be A of T is equal to 15T. So $15 times the number of tickets that you buy would give you the total amount that you're spending on tickets. When it comes to listing the domain and range of the function, you could buy either 0, 1, 2, 3, 4, 5, or 6 tickets. And one way that we can write that down is to represent it as a list. And then for the range, you would think about each of those corresponding output values. So if you bought 0 tickets, you would spend $0. If you bought 1 ticket, you would spend $15. 2 tickets would cost you $30, right? Because 2 times 15 is 30. And then you would finish that list. So buying 6 tickets would cost you $90, and that's where the list ends, because up above it says you can only buy up to 6 tickets. The next question asks us whether the graph is discrete or continuous, and it wants us to explain this graph would definitely represent discrete data because only whole number inputs are logical. You can't buy half a ticket, and so because of that, we would not draw the line when we create the graph. And so our next job is to do that. We're going to create the graph. Our x-axis represents the number of tickets that we buy, so buying 0 tickets would cost $0. Buying 1 ticket would cost $15, 2 would cost $30, and so on. Even though these points follow a straight line, remember, we're not going to draw the line because it's a discrete function. The next couple of questions have us answering questions about the function notation. So explain the meaning of A of 0. A of 0 would be the cost of buying 0 tickets. You can tell by looking at the graph, if you bought 0 tickets, you would spend $0. So the value of A of 0 would equal 0 in this problem. The next question asks us to explain the meaning of A of -4. So A of -4 would mean how much it would cost you to buy -4 tickets. But that doesn't make sense here in the context of this problem because you can't buy a negative number of tickets. So that would be a non-logical value. The next question wants you to explain the meaning of A of T is equal to 150. So in this problem, that would represent how many tickets you could buy with $150. Think about it. If each ticket costs $15, then you could buy 10 tickets, right, with $150, except in the directions to this question up above, it stated that you were limited to buying 6. So even though 10 tickets would cost you $150, in this question, you're limited to only buying 6, so you could still only buy a total of 6 tickets. And then in the last question here, it says to explain the meaning of A of 5 is greater than A of 3. So A of 5 would be how much buying 5 tickets cost, and we know from up above that that would be $75. A of 3 would represent how much buying 3 tickets costs, and so we know from up above that that would be $45. And so when we say A of 5 is greater than A of 3, what that means is buying 5 tickets would cost you more than buying 3 tickets would cost you. So it's just a way of symbolically representing the situation and what's going on here in this particular word problem. All right, the last problem for today describes a situation where 3 friends are floating in a river, and they're noticing that the water level is higher in some places than in others. And so the table here represents the time in minutes and then the depth of the water in feet. We're going to use this table to interpret the key features of the relationship. Remember that time equals 0 represents what's happening at the start. So the first question asks us what was the depth of the water at the very beginning. When time equals 0, it looks like the water was 4 feet deep. The next question asks us what was the depth of the water at the end. And based on the information that's provided to us in the table, it looks like their trip was about 2 hours long, right? So 120 minutes. And so at the end of their trip down the river, the water level was 5 feet. Question C wants us to know when does the water reach its maximum depth and how deep is it at that point? So this is a 2-part question. To answer this one, we have to look at the time and we have to look at the depth in feet. It looks like the biggest number for maximum depth happens here when the depth is 12 feet. 12 is the biggest number as you look through the depth row of this table. And so at 90 minutes, the water is 12 feet deep. That's the maximum depth. Question D asks us, true or false, the depth of the water increases and decreases throughout the 120 minutes of floating down the river. And by scanning through the depth row of the table, you'll see that that's true. The depth of the water goes up and down as they float down the river over time. So the numbers on the depth row are increasing and decreasing. The next question wants us to ask if whether it's true or false that the water level is a function of time. And that's true because at no one time is the water equal to 2 different depths. There are different depths that repeat themselves, but remember, it's okay if the y's repeat themselves, but at every x, each x gets matched up to just one y. The next question asks us to explain the meaning of D of 40 and what does this mean in the context of the problem. D of 40 means how deep is the water at 40 minutes. And so if we go back up to the table at 40 minutes right here, the water is 6 feet deep. So d of 40 would equal 6. And for the final question, explain the meaning of d of t equals 8. What does this mean in the context of the problem? This is asking a different question. D of t equals 8 is asking us at what time does the level of the water equal 8 feet? And so if you look for 8s in the depth in feet row, you'll see that that answer lies here because that's when the depth of the water equals 8 feet. And so we can say that here d of t equals 8 occurs at t equals 20 since the water level equals 8 feet at 20 minutes.